And hopefully today all your questions and everything, whatever you speak, that will also get recorded today. Okay. Yeah. So up to the previous class, what we had done is we had just started talking about the relation between coefficients and zeros of polynomials, right? So see, we are here right now. We did this for linear polynomials yesterday. We understood that how linear polynomials, the standard form is ax plus b. We can use that and we can find that the zero of this linear polynomial will be a very simple formula. It will be just minus b by a.
Sir, your screen is not shared, sir.
Oh, you're not seeing my screen? Okay.
No, sir.
Yes, yes.
Okay. Tell me if you can see now.
Yes, sir.
Yeah. So this is what I was talking about. Yesterday we had talked about
So
relation.
you're once again teaching polynomials, sir?
Yes, we have started with polynomials now.
Yes, sir. No, sir.
Yeah.
Last year also you.
Yeah. We did that but a lot of other students have joined, so they had not completed. So
Yes,
anyway,
sir,
like I said that we will go through this again anyway, thoroughly, fully. So we have done
yes,
this.
sir.
So if you have done this, of course, but now you have to do this in the notebook which I have asked you people to buy. Okay.
Yes, sir.
And you will maintain record of whatever we are doing, and all these notes, whatever I'm sharing, you will keep it with you.
Yes, sir.
Okay. Yeah. So what
Sir, I'm using 2 gadgets, sir. Is that okay?
you are using what?
That yes, sir. I'm using Jagadishwaran account. You can see, no, sir.
That's okay. That's not a problem. Don't worry about that.
Okay, sir.
Yeah. So what I was saying is, up to yesterday's class, we had talked about relation between coefficients of zeros and polynomials. We had discussed about linear polynomials, and zero of a linear polynomial is very simple formula minus b by a. And I had said that today we will start with quadratic and cubic. But before we go ahead, we have done a lot of theories. So let's do some question solving today, okay? I'll give you some questions. You will quickly solve it. Are you all ready? Take out your notebooks, pen, and be ready to solve some questions. These all should be easy questions, but if you have a doubt, you will ask me. What is left inside? Everyone can see the question. It's clearly visible.
Yes, sir.
Okay. Our origami is ready. Tanushree, if you are using two things at the same place, that's why you are getting this echo, okay?
Okay, sir. Sir, in classwork we have to do or in math test note?
Not in the test note, you just do it in the tuition note.
Okay, sir. Try करो.
Sir, done, sir.
Okay, tell me. What is the okay? Don't tell me the answer right now. Hold on, keep it with you. Let other people finish and then.
Completed, sir.
Completed, sir.
Okay. So all of you who have completed, check the answer, match it. If it is correct, you.
Yes, sir.
If your answer is correct, put it in the chat window that I got the right answer, whatever. Got it right, whatever. Something. Send you a message through the chat window. Is it difficult to type or it's very easy? On your phone. Easy, right?
Yes.
Okay. So Kavya, Nitya, Pragati. Ramachandran. This is Tanushri, is that you? Jagadishwaran Ramachandran.
Yes, sir.
Okay.
Sir.
Okay. This is Medula. Ritesh. Okay. All of you got right. What about Deep, Charan? Too easy question. No need to waste time.
Yes, sir. Got, sir.
Yeah, that's okay. Fine. So, okay. So there is not much to ask right now. So I will give you more questions later. But for now, what kind of polynomial was this? What kind of polynomial is this?
Quadratic.
Yes, it's quadratic polynomial. And what is this P? How do you read this thing? How do you read this?
P of 3, sir.
Yes, you read it as P of 3. What does it mean? It means you're finding the value of Px for x is equal to 3. Okay. Now, when you found P of 3, what is the answer you got? 0.
0, sir.
So what does that make this 3 as? What is this 3 now?
0 of the polynomial.
0
sir.
of the polynomial.
Yes. So 3 is the 0 of polynomial px. Okay, but you notice that it's a quadratic polynomial, means it has a degree 2. So what do you think? It can have more than one also, right? It can have up to 2 zeros it can have. So first one is 3, and just now you saw that the other one, when you put p equal to -1 also, still you get a 0. That means -1 is also a 0 of this polynomial, correct? -3 and -1. Okay, so what happens when you have a quadratic polynomial? What is the standard form of quadratic polynomial? Yes, go ahead, tell me.
ax square
plus bx plus c.
Yes, it's ax square plus bx plus c. Absolutely right. Now, this polynomial can have 2 zeros, right? So those 2 zeros. Hold on, guys, 1 minute. Just. हाँ ठीक है, देखने दो, मतलब अगर कुछ जरूरत होगा तो मुझे बोल देना। अभी है ना वहाँ पे, ठीक है। Yeah, guys. So what I was saying is, you have this quadratic polynomial, and once if you have a quadratic polynomial, it can have 2 zeros, right? So let's give the 2 zeros some name. So the first 0 I'm going to call alpha from now on. Okay, this is the first 0 of this polynomial. And the second 0 I'm going to call as beta. So alpha and beta are the 2 zeros of this polynomial. If I take up the example which we just now solved, x square minus 2x minus 3. Let me take that example. It's x square minus 2x minus 3. So what are the coefficients over here? Tell me, what is a, what is b, and what is c?
A is 1, B is 2, and C is -3.
Is that right? Everyone agrees?
sir, -2
No, sir.
for b.
Yes, we need to consider this sign also, okay? So be careful with that. I know you already know this, but you should be careful with this. And that too, I wrote it a little bit further apart, so don't get misled by that, okay? So this is -2 is the coefficient of x. So b is -2. All right. Now we already found the 2 zeros of this previous polynomial. 3 was one of the zeros, -1 was another 0. So now there is nothing like no rule that alpha has to be 3 or -1. You can call anyone as alpha, anyone as beta. So let me call alpha is equal to 3 and beta is equal to -1. Does it make sense now? Alpha and beta are the zeros, means for this polynomial, alpha can be 3, beta can be -1. A, B, and C are the coefficients. Everyone is with me so far? There is no confusion about this. Anyone has any question in this?
Sir, couldn't get you, sir.
No,
Can
sir.
you explain one more time, sir?
Okay. Okay. So what I am talking about here, Midula, this is your quadratic polynomial, right?
Yes, sir.
I said that quadratic polynomial can have two zeros because they have a degree of 2, right?
Yes, sir.
So I'm giving them some name like alpha and beta. So from now on, whenever I say alpha and beta, you will understand that they are the zeros of this quadratic polynomial, alpha and beta. Okay. Alpha can be the first
Sir?
zero. Yeah.
So are these zeros actually called as alpha and beta, or are you just for our reference you are saying?
No, this is a very common notation. Everybody uses this notation. It's there in your book also. You'll be using that notation every time, not just me. Okay. I'll show you that. We will derive formulas, we will derive the relations, and then it will become more clear. Okay. Yeah. So Midula, what I was saying here is I have just taken an example. You just solved an example, right? X square minus 2x minus 3.
Yes, sir.
This is just an example. So here I have just taken apart the coefficients. The coefficients are a, b, and c, and alpha and beta is going to be 3 and minus 1, because we have just now found for this polynomial the zeros are 3 and minus 1, right? So alpha is going to be 3, beta is going to be minus 1. I am just telling you that the notations alpha and beta, what it means to be saying that alpha, what is beta. So is that part clear?
Yes, sir.
Okay. Now let's get into the thing which we have been talking about in the previous class. I said that we are going to talk about the relation between the coefficients and the zeros, right? Relation between the coefficients and zeros. So when I say coefficients and zeros, what are the coefficients? A, B, and C are the coefficients. What are the coefficients? A, B, and C. And when I say relation between coefficients and zeros, what are the zeros? Alpha and beta. So now you have to find a relation between these coefficients and these zeros. Okay. Just take you back to the linear polynomial. For linear, what happened? There was only one zero. So let that be alpha. For a linear, there's only one zero. So there'll be no beta, only alpha. And that alpha was equal to what? What was the formula we had derived?
Minus b by a.
Minus b by a. So there was only alpha, and that has a relation with the coefficients a and b. And that relation is alpha is equal to minus b by a. This is the relation.
So cubic polynomial will have 3 zeros, sir.
Yes, cubic will have 3 zeros.
What about the third zero? How will we call it, sir?
We will call it as alpha, beta, and gamma. A third one will come as gamma. I will show you that also, okay? If there is a fourth degree polynomial, then you will call it as alpha, beta, gamma, and delta. Okay?
Okay, sir.
Sir, for 5 degree?
We can give them any names. Like you never have to go beyond 3 as of now. For your 10th standard, you will be, most of your questions will be based on quadratic polynomials. You might get few questions based on cubic, okay? You never have to go beyond that for now, for your 10th standard. So don't worry beyond delta, okay? See, alpha, beta, gamma, delta, all these are Greek alphabets, like A, B, C, D, okay? Alpha is A, beta is B, gamma is G, delta will be D for them, okay? So ABC we are using as coefficients, English alphabets, Greek alphabets we are using for zeros. Okay, so linear relation is clear. Now in this part, we are going to understand the relation between the zeros and coefficients of quadratic polynomial. So those of you who had already attended, anyone knows what is the relation? Do you remember? No? Okay.
Can you repeat the question, sir?
I'm asking, anyone remembers what is the relation between these alpha, beta, and ABC? Is there? Do you remember this? From the
Sir, it
previous?
is ABC in Greek words, sir. In Greek language.
Yes, but like I said, for a linear polynomial, alpha was equal to minus b by a, no? So like this relation, do you remember for quadratic, what is the relation?
Yes, sir. Alpha into beta will be minus c by a. Then minus ca, sir. Then alpha plus beta will be minus b by a.
Alpha into beta is how much? Say that again.
Alpha into beta will be minus b by a, sir.
Okay.
Then alpha plus beta will be ca.
Ca like this.
Yes, sir.
Okay.
No, sir. C by a, sir.
C by A. Okay, so you are very close. You just flip this. This should be alpha plus beta, and this should be alpha into beta. Okay, you just have to replace that. So you are very close. Okay, that's good. So at least you remember that much. Alpha plus beta, this is the first one. That will be minus B by A, and alpha into beta, that will be C by A. Don't worry if other people, if you're not understanding what I'm saying right now, I'm going to explain this. Okay, don't worry. Okay. So see, for a linear, it was very simple. There was only alpha, and we said I can directly find the value of alpha by saying B by A. But here, why am I not writing alpha is equal to something? When I said relation, I should be writing alpha is equal to something in terms of ABC, right? But I'm not doing that, because when you write alpha is equal to in terms of this ABC, the formula is very complicated. And you will learn that in quadratic polynomial, quadratic chapter, okay? You will learn that. So I'm going to write that thing also for you. Actually, we can directly find alpha using ABC. And the formula is like this. Alpha is equal to minus B plus square root of B square minus 4AC by twice A. And same way, beta I can say minus B minus B square minus 4AC by 2A. Does it look scary?
Yes, sir.
Yes, I know it looks scary. That's why you don't have to study about this right now, okay? We will study this only in third chapter, not third chapter, quadratic polynomials chapter, whatever chapter that is, okay? So don't worry about this right now, as of now. Just remember, if you want to find alpha directly, that can also be done, but the formula is little complicated.
Sir, you should have said in +2 we will study this.
No. See, this may look scary, but it's not that scary, okay? Once you learn this, no, it become very easy. It's actually, this is your best friend. This will become your best friend in your exam. You will understand why, okay? Don't worry. That's why I made you familiar with this right now, because this is going to be your friend later. So I'm showing you, but right now we are only going to talk about these two guys. I'm not finding alpha and beta directly, but I'm saying that when I take alpha and beta, and if I add them, the sum of those zeros, it will be equal to minus B by A. This looks like a simple relation, no? Easy to remember. No problem with this?
Sir, can you repeat again what you said now?
Yes, I'm saying that this relation which I'm showing right now here, this is called sum of the zeros or sum of roots. Sum of zeros. The two zeros are alpha and beta. We are doing an addition, no? That's why we are calling sum of zeros. What is the sum of zeros? It's very simple. It's B by minus of B by A. Okay, and then alpha into beta means it is a product of zeros. So this you will remember it as product of zeros. And that relation is very simple. It's C by A. Is that clear? How this came, the derivation, that I'm going to tell you. But for now, let's start with easy things. Let's just understand the simple relation. You remember this minus B by A, I'm going to remove this part from here, okay? Because this is something which you're going to learn later. So let me remove it from here, okay? And this also, let me write little neatly. So when I'm talking about relation, it starts with sum of zeros. Sum of zeros. And it will be alpha plus beta, and it's going to be minus B by A. Remember, this minus B by A was directly the value of alpha in the linear equations. Remember? Because there was only one root, 1 0. So sum of zeros will be minus B by A, and we were able to directly find the alpha. There was nothing else to add to alpha over there. That is why I directly gave the answer. But here we have more than 1 0. That is why minus B by A is a sum of these zeros. And product of zeros, it will be alpha into beta. This is going to be C by A. And I want you to remember this by heart. You should remember this. Whenever I ask you what is the formula for sum of zeros, you should be able to vomit this out within fraction of seconds. Okay, that went too bad. Don't vomit. Just tell me the formula. Okay, will you be able to remember this, all of you? Very easy, right? Minus b by a and
Yes,
c by a.
sir.
Yeah. Okay, now what I'm going to do, whatever example we had taken, we had a, b, c values here, alpha and beta also. So let's check it, whether it really works or not. This formula sir gave, but does it really work? So let's take that same example. What is alpha and beta here? 3 and minus 1. So let's do the verification. So what was our px? It was x squared minus 2x minus 1. Oh, minus 3. Okay. So a was 1, b was minus 2, and c was minus 3. You had already told me this, so everybody knows about this. Okay, that's why I'm writing a little fast. And what was alpha and beta? Anyone remembers?
Alpha
Sir, 3 and minus 1.
3 and minus 1. Okay, let's try to verify the sum of roots here. So sum of zeros, and sum of zeros should be alpha plus beta, and this should be equal to what? Minus b by a. Now what is my alpha here? It's 3, and what is the beta? Minus 1. So 3 plus minus 1 should be equal to minus of, what is the b value here? Minus 2, and what is the a value here? 1. I'm just putting the values over here. Does it make sense to everyone? Everyone understand what I'm doing here?
Yes, sir.
Okay, good. Now let's verify and see whether it's equal or not. 3 plus minus 1, it will become 3 minus 1, and minus will become 2, and by 1, no need to write it. So 3 minus 1 is 2. This is also 2. That means our LHS is equal to RHS. So we have just now verified that when we take the roots 3 and minus 1, if we add them, it actually becomes equal to minus of b by a. Make sense?
Yes, sir.
Okay. Now let's do the same thing for product of zeros also. Okay. Let's do it at the same page. So product of zeros. What should be the formula? Anyone remembers?
C by A.
Very good. C by A. So what should I write here?
Three into minus 1.
In place of alpha, we'll write 3. Very good. And in place of beta, we will write minus 1. So 3 into minus 1 should be equal to C by A. So what was our C? Minus 3, and A was 1. As you can see, this is also minus 3, and this is also minus 3. LHS is equal to RHS again. That means whatever sir said, sir knows the formula. He's not lying. Uh-oh. Okay. So alpha plus beta is C by A, and alpha plus beta is minus b by A, and alpha into beta is C by A. We did the verification. So you might get questions like this also. They'll give you a polynomial. They will ask you to find the zeros. They will ask you to find this alpha and beta, and then they will ask you to verify whether sum of zeros and product of zeros really works or not. Okay. So you people have solved quadratic polynomials, right? Factorization you would have done in 9th class. Everyone knows how to do factorization? Splitting the middle term.
Yes, sir.
Yes, sir.
Okay. So in this question, which I had taken in the beginning of the class today, Here, the polynomial was given x square minus 2x minus 3. We found this p3 and p minus 1. I directly gave you these zeros, okay? But that may not be the case always. They might ask you to find it and then they will ask you to verify. But for now, let's take some questions where I will give you the zeros and you will just verify them. Okay, so let's start with question number 2 for today. So this question, what they're asking you to do, they're saying that there is a polynomial 6x squared minus 7x minus 3. So first they said find the zeros. Okay, do you know how to find it? How many of you know? Say yes or no. Give me a yes or no in the chat
Sir,
window.
no, sir.
Not sure? Okay,
Yes,
fine.
sir, yes, sir. I know, sir.
You know, okay. See, all you have to do is split the middle term, find the factors, make it equal to 0 and find the value of x which makes them 0. So I will solve it anyway, but if anyone can do it, try to do this on your own. I'll keep solving it here. I will find the zeros. Okay, but before we start doing all that, let's try to complete the question. What we have to do after that, we have to verify something. Means LHS is equal to RHS we have to do. What we have to verify? The relation between the zeros and the coefficient. And just now you learned, for a quadratic polynomial, what is the relation between zeros and coefficient? What are they asking us to verify? They're asking us to verify whether alpha plus beta, is it equal to minus of b by a or not? And alpha into beta, is it equal to c by a or not? This is what they are asking us to verify. Okay, so
Yes, sir.
So in this question, px is already given. Those of you who know how to solve this, you can start solving on your own. So px is given as 6x squared minus 7x minus 3. So ABC is very easy to find. What is my A here? What is A here? It is 6. B is minus 7. Minus 3. So ABC is very easy to find. But to verify this relation, I need the alpha and beta also. So this question, we have to find the zeros. And how do we do that? By factorization. So let's factorize 6x squared minus 7x minus 3. Let's not write it like this. Okay. Okay. Now, to find the zeros, we have to do factorization. And for factorization, what we have to do, we have to take the coefficient of x square and the constant term and multiply them. So 6 into minus 3 becomes minus 18. This is what we need to split up And we have to split it up in such a way that when we add or subtract them, it should become equal to the middle term, which is -7. हो गया ठीक? नहीं पानी पूरा ऊपर ओवरफ्लो हो रहा है फिर इससे बोल रहा है कि खोल के गाड़ी से पाइप लगाता है अगर नहीं करना वो करना पड़ेगा पानी पूरा ओवरफ्लो हो रहा है भर गया है वहाँ पे ना 1 मिनट प्लीज नहीं ठीक है उसको बोल दो कुछ भी है तो हाँ हाँ बात कर लो देना है कुछ पैसा क्या नहीं तो भैया बात कर लेंगे बाद में बोल दो हम बात कर लेंगे बाद में कॉल कर लेंगे शाम में कॉल कर लेंगे yeah sorry about that okay so what I was saying is you have to do the splitting the middle term and how did we learn it we will try to do all the factors of it 1 into 18 makes it 18 2 into 9 makes it 18 and no need to go further 3 into 6 also makes but since we have to find 7 for addition and subtraction this 2 and 9 is going to do the job for us so how should we do it which one should I take negative 9 should be taken as negative and 2 should be taken as positive only then I will get -7 over there so I will have to split it up like 6x squared minus 2 plus 2x minus 9x minus 3 so -9 and plus 2 becomes -7 so we didn't change anything we have just split up the 7x as 2x and -9x okay so this is something you should know from your previous class but if anybody needs with this factorization or splitting the middle term you can ask me later I will help you separately with this okay yeah so let's take the common 2x is common here so 3x is remaining and here +1 same way -3 is common and 3x +1 and this will become 2x minus 3 and 3x plus 1 so these are the two factors so I've got the two factors this is one factor and this is another factor now to find the 0 it's very simple the polynomial will be 0 only when one of these factors is 0 so if 2x minus 3 is 0 then what will be the value of x 3 will go to the other side it will become +3 and 2 will come down as 3/2 so this is simple equation everybody knows how to solve this okay or if the other one is 0 that is 3x plus 1 is 0 then x should be equal to 1 will go to the other side it will become -1 and 3 will come down so it will become -1/3 so now we have found the two zeros of the given polynomial and let's try to put them in the notations also we have been using the notation alpha and beta for that so let alpha be equal to 3/2 and beta is -1/3 everyone is with me so far alpha and beta now we have found it and you will do the verification I'm not going to do that for you just now we did this verification right alpha plus beta minus b by a alpha into beta c by a so try to do that verification for this
Done, sir.
okay you verified it
Yes, sir.
okay good we'll say alpha plus beta it should be equal to minus of b by a alpha is 3/2 plus beta is minus Okay, so 3 by 2 plus minus 1 by 3 should be equal to minus of b by a. What is a and b? We had just found it earlier. B and a is minus 7 and 6. Minus 7 and 6. Remember, don't forget when there is this one is negative, don't forget to put this minus sign. This minus is separate, and then if b is negative, you have to put that minus again one more time, like minus 7 here. So be careful with that. Then 3 by 2 minus 1 by 3 is equal to 7 by 6. Is that right? 9 minus 2 by 6. This is 7 by 6. This is also 7 by 6. Verified. Let's do the same thing for product of roots also. Alpha into beta will be c by a. So 3 by 2 into minus 1 by 3 should be equal to c by a. What was c? Minus 3. So c is minus 3 and a was 6. So if I cancel this 3 and this 3 will get cancelled, it will be minus 1 by 2. And this was 3 1s are and 3 2s are. This will also get minus 1 by 2. Okay. So today you have learned how to find the zeros of a polynomial and how to verify the relation between 0 and coefficient. Of which kind of polynomial? Of quadratic polynomial. Okay, fine. So we have exceeded today's time a little bit for maths, but this was important to complete this one question. Okay, so you make sure you go through this video again and revise, and in the next class I will give you more questions based on this. Okay, so that's it for the maths class. Those who have to attend science class, you will take a break of 10 minutes and then come back. Okay.
Excuse me, sir.
Yes, Charan, tell me.
Sir, for now I will only come for max tuition. I am not comfortable with online.